If I ask you, write electron configuration of bromine, and you look at bromine in periodic table, and how many electrons in bromine? Do you see there are 35 protons and 35 electrons in bromine, Br. So you write 1s2, go to next level, higher energy level, 2s, only 2. Next one is R 2p's. There are 3 orbitals, each pick up 2 electrons, 3 times 2 is 6. Next energy level is 3s with 2 electrons. Next is 3p with 6 electrons. And 4s is the next one. S is a single orbital. Each orbital can take maximum of 2 electrons. And 3d is the next higher energy. Remember we said they are coming as quintuplets. So 5 orbitals, each can pick up 2 electrons. 5 times 2 is 10. That's maximum number that the orbital can take. And what comes after 3d, 4p? Remember, p's are triplet sister. They can accommodate a maximum of 2 electrons each. 3 times 2 is 6. So, but you only have 5 electrons. These 5 electrons are going to be occupying the 3p orbitals of p subshell. So are you with me so far? Because I don't have an audience, this is asynchronous, please make sure to come to my office hour links. And also every afternoon, Monday through Thursday, there is one of the instructors waiting for you on Zoom. Starting from 1 goes to 350, and one of them is from 2 to 5. For this, just check the Shasta Zoom, or the links are changed and you're there. The new links are there. Click on the link. It says lab work time or lab time. So office hour or lab time is for you to come and ask questions from the 4 instructors, of which I am one of them, teaching this course. So guys, you learned how to write the electron configuration for bromine. Sometimes we want to write shorthand notation, and we call shorthand notation of electron configuration noble gas notation. Why do we call them noble gas notation? Okay, if I look at total electrons which are used here is 2 plus 2 is 4 plus 6 is 10 plus 2 is 12 plus 6 is 18. And if you look at the table, you will see on column 8A or column 18, you're going to see number of electrons in argon is 18. So in order to do the shorthand notation, I'm going to say this is noble gas configuration for argon. And I'm using bracket. If I place AR, argon, in a bracket, it means electron configuration. It means this. So in noble gas notation, I'm choosing a noble gas which belongs to the last group on the right of periodic table. I use this shorthand notation, which means all of these. And then I write what is left over. Let me clean this up. Can I say these are beyond 18 electrons of argon? So I write them immediately after bracket argon. So that's how you write noble gas notation. And if I go to the next slide, I want you to write these configurations. And we want you to write complete electron configuration once, and then write noble gas notation, and then without looking at at the answers, write the answer on a piece of paper, then go ahead, compare the answers, see if you got the correct solution. If you couldn't figure out why, make sure to come to my office hours or the lab hours, which is every afternoon, and ask questions on Zoom. Next, I'm looking at periodic table and group number. There is a system of numbering which you, for every column, this is column number 1, this is column number 1, this one. So we show this as column 1 and A, 1A. This next column, column 2A, column 3A, 4A, 5A, 6A, 7A, 8A. If you look at this type of column number, where there is a number and letter A, capital A, uppercase A after them, they really relate with number of electrons in the outmost shell. So all of these in group 2A, they have 2 electrons in the outer shell. And all of them in group 1A, they have 1 electrons in the outmost shell. And the same for group 3A, they have got 3 electrons. 2 of them are in 2s. 1 of them is in 2p, or 2 of them are in s, 1 in p. So all of them have 3 electrons in the outer shell. And the same for group 5A, 6A, 7A, 8A, except for helium, which is exception. All these have 8 electrons in the outer shell. Helium behaves like noble gases. Group 8A is called noble gases. What is their novelty? They are most stable. They don't want to react. They are more stable than any other element in periodic table. So helium is exception because it has only 2 electrons. It can't have 8 electrons in the outer shell. But the rest of these elements in group 8A, they all have, look, 8 electrons, 8 electrons, and 8 electrons in the outer shell, and they belong to group 8A. All right, so this is the periodic table. Do you see that there are 2 systems of numbering, 1A, 2A, 3A, 4A, 5A, 6A, 7A, and 8A, that you could use this to predict number of electrons in the outmost shell? But this is only valid for these. This rule is valid for these elements and these elements. What do we call this? Main group element. It's not valid for transition metals, which is up to here. And these are called inner transition metal. For these also, what we said is not valid. You cannot determine number of outer shell electrons simply using by the column number, which is followed by a letter. Now, in the newer table, you may not see these numbers which follow with A, but you can predict them. In the newer table, you see column 1, 2 going all the way to column 18. So, if I want to determine this column, how many electrons in the outer shell, I need the column number here, which is not printed on some of the newer calendar. All you have to do, write number 13 minus 10, you get 3A. Number 14 minus 10, you get 4A. So write these newer numbers, which are larger than 8, minus 10. So I don't know what is the group number. I write 16 minus 10, I get 6A. That means there are 6 electrons in the outer shell. Here, group number 17, minus 10, 7A. So therefore, there are 7 electrons in the outer shell of these. Okay. So again, atomic number, which appears on the top of every element in periodic table, is going to give you number of protons. And for a neutral atom, that means an atom who hasn't lost electron or gained electron, no, atomic number, which is number of protons, is equal to number of electrons. So that's how we know that carbon has got 6 protons. It also has 6 electrons. This is an arbitrary symbol we use for elements, C for carbon, and the number underneath in periodic table shows atomic weight. Do you remember for carbon we have 3 isotopes earlier on this chapter, previous section? You can look at the previous recording. We said all elements have more than 1 isotope. So if I want to write weight of 1 atom of carbon, because there are 3 types of atoms of carbon, which are only different by their number of neutrons. So we have 3 different weights for heavier atom and lighter atoms of carbon. I showed you a formula that you can multiply abundance, percentage availability of each carbon times the weight of them. So what we write here is an average weight of an average atom of carbon. Because table has 1 location. So this is an average atomic weight of an average atom of carbon. Okay, if I go to next slide, again, I want to show different parts of the table. Let me go back and go back to the table. Actually, this table, this table, this table, this table. So I want to show what are different parts of the table. Well, can I say, I'm cleaning up, can I say these parts, as I said before, these and these make main group, they are called main group element. And these and these and some of these, they behave like transition metal. So these are transition metal. And if you look at this bottom box, look at 57. What comes after 57? 58. These are atomic number of protons. And look here, it's 71. What comes after 71? 72. So do you see that this box of elements, they are coming from this area. They have been taken out. So we call these inner transition metal. These are transition metal. These are taken from inside of transition metal. So we call this inner transition metal. Inner transition metal. Metals. So guys, pay attention. What is the element which comes before atomic number of 58? Do you see 57? The name of the element 57 is lanthanum. And because this whole row is coming after lanthanum, they're called lanthanide. The next row, atomic number 90. Is it fair to say 90 is the number after 89? And the name of element 89, actinium. So we call this second row as actinide. So these are different parts of the periodic table.